Hello everyone. Today we have a tricky question. Given a list of numbers, sorted list of numbers, remove all duplicates, and the requirement here is to remove it in place, not allocating any extra space. So, well, it's easy to remove duplicates. If we allocate extra space, we can use hash table for it. To have only unique numbers, and looking into hash table is only constant time, so it's easy. But how to do it in place? Well, the trick here is that we should use the sorted property. So basically the approach here is to use two pointers, one slow, second fast, and we assign the index 0 to the slow pointer, index 1 to the fast pointer. This is our start point. And we only move our fast pointer along the way when we encounter duplicates. And once we encountered a unique number, the number that we haven't seen before, we increment the slow pointer by 1 and assign this new encountered number to this index. That's it, and we continue along the way. So yeah, let's look how it works. Remove duplicates. Okay, so we have a test. So basically the test is falling now because we just returned none, and we okay, so let's solve it. Okay, index I is 0, and we need to loop for G in range 1 length numbers list. Okay, if enums I is not nums G, is not nums G, we want increment I, and we want assign the nums G value to on the index I. Okay, that's it. And in the end we want to return so we don't allocate any extra space, so we don't clone array into, we shouldn't clone array into a new array. We just need to return index where the new slice of this array that contains no duplicates finishes. So it is I plus 1. Okay, let's execute it. Yeah, good. True, our test passes. So now let's debug it. Okay, we have our I on index 0, and we go into the loop. J is on index 1, so we check if I not equals to J. Basically I points to 0 and J points to 0, so it is not the case, so we just move along our fast pointer J. Okay, we on a second index. Is element on second index different from element on the 0 index? Yes, it is different, 1 and 0. So what we do, we increment the slow pointer I, so now it is 1, and we assign 1 to the index 1. Good, you see 0, 1. Okay, so let's move our fast pointer along the array. Yeah, we just move in, you see, because basically we have all duplicates here. And when we on the index 5, we encountered number which is not equal to the number to which the slow pointer points. Thus we increment the slow pointer by 1. Now it is 2, and we assign 2 to the 2 index of this array. Yeah, good. And now it is 0, 1, 2. Well, and now we are ready to return it. So I is equal to 2. So basically we return I plus 1, 3. So meaning that from 0 up to 3, not inclusive, we have an array where there are no duplicates. And what we have to the right doesn't matter, because the requirement here is to remove duplicates, and basically we doesn't care what the array holds after that index to the right. It can be numbers without change, or they can be overwritten by another elements and another values. Doesn't matter. So the time complexity here is linear, because we loop through array. The space complexity is 1. It is big O1. It is constant because we don't allocate any extra space. Okay. And again, if we want to use our result later in our program, basically we check only that part of array where the numbers are unique. And it is easy to do it because we know where the array with unique numbers finishes. It finishes on a index on index 2 before 3. Okay, good. That's it. Thanks for your attention. Have a great day.